Good morning, friends. Good afternoon, rather. So we start. Well, just to introduce myself, I am Ravinder Kaur from the Department of Geography, and I shall be speaking on Geographic Information Systems. This is the layout of my presentation. I shall give a brief introduction. What is GIS? I shall give a description on the components of GIS, types of data, tools of GIS, GIS functional elements, and benefits of GIS, and then GIS as a multidisciplinary science. I begin. Well, GIS comprises of three words: geographical, information, and systems. Each of this word used in this technology has a meaning. When we use the word geographic, it means that this phenomena is going to deal with locations. In geography, we deal with locations, and in GIS, we work on locations. And when we work on locations, we are in fact working with relative locations and absolute locations. In GIS, we are more concerned about absolute locations. Now, absolute locations are referred in the terms of latitude and longitude. This signifies the word geographic. This signifies the words information. And this signifies system. Now we ought to understand the meaning of these three terms that shall make the entire technology very clear. The idea of using the word geographic is that we are going to work on locations. In geography, you express location in terms of XY coordinates, which are known as latitudes and longitudes. Whenever we work on locations, there are two aspects which are supposed to be considered. One is absolute locations. These are absolute locations. And then we work with relative locations. Relative locations are expressed in terms of distance, time. They may be and they're always expressed in relation to some other known location. So this is clear. When we go to the second word, that is I, this stands for information. It means that we are going to work with some database. Now, over here, I would draw your attention to differentiate between data and information. When you have number of raw facts gathered together, we call them data. And when you try to cull something meaningful out of it, we call it information. Now, working in this GIS environment, we are going to work with a lot of database, trying to cull out very important and meaningful information. The word system denotes computer and its peripherals. This gives a fair good idea that you are going to use the computer as a system with hardware and software. And that is why the nomenclature GIS gives you an idea that you are going to work on geographical locations, you are going to work with database, and this database may be spatial database and attribute database. And in the we'll discuss this at length when we discuss further. And then the system word connotes that we are going to use computer and its peripherals. Now the geographical information system is a special class of information system that keeps track not only of events, activities, things, but also of where these events, activities, and things happen or exist. Word where signifies location. Geographical location is an important attribute of activities, policies, strategies, and plans. Geographical problems involve an aspect of location, either in the information used to solve them or in the solutions themselves. Now, what is GIS? GIS is a structure which contains spatial information along with its non-spatial information. Now, we need to understand these two words. What is spatial and what is non-spatial? Spatial means when you deal with geographic space, the environs around you, and most of the spatial data is in terms of latitude and longitude. GIS is a system to capture, store, and manage and analyze spatial and non-spatial information. Now, the question arises, what is non-spatial information? Non-spatial information is also called attribute information, which means that whenever you have attributes which try to explain your spatial elements or your locations, for example, if you have a location on the map which portrays any location of a city, now this latitude and longitude or these X and Y coordinates of the city become spatial information for you. But when you have a lot of data on the attributes about that city, in order to know that city better, whether it is demographic data pertaining to total population, sex ratio, workers or women participation, flora, fauna, meteorological data, and number of elements or attributes you can have. But that gives you a fair good idea of that particular location. So this data is known as non-spatial data or attribute data. Now, we also see GIS as a computerized data management system which is used to store, capture, manage, retrieve, analyze, and display spatial information along with its attribute information. Now, when we are talking about these words, capturing, storing, managing, retrieving, analyzing, these are all capabilities that a computer promises you, because we use computer as a major device, and all the inherent capabilities of a computer are offered to any user who chooses to work in GIS environment. Now, this is how one understands. These are geographical positions or locations, and we have built up information system which is based on data. And when you use geographical information, it provides the capability of integrating this information with the spatial data or geographic positions. So you have spatial database and you have attribute database. GIS will be a technology using computer hardware and software. It is going to integrate the spatial as well as non-spatial data. And when you integrate it, you are able to get some more information, and this information is used to solve the real world problems. And these days, that is why GIS is in great demand and is also used as decision support system. Your decisions shall be taken on the basis of data, and whatever decisions you take, they are going to be precise and objective, and that is why people call it decision support system. Now, coming to components of GIS. A GIS can be divided into 6 components. We have people, procedures or methods, hardware, software, data, and network. People are the viewers, they are general users, and they are GIS specialists. When we talk of procedures, these are steps taken to answer the question which needs to be resolved. When we talk of hardware, it's a computer system and its peripherals. We talk of software, there are different GIS software packages like ArcView, ArcGIS, and then we have data statistics, which are crucial to check the quality of the data before obtaining it. You have so many data sources. And when you have so many data sources, you need to use most of the data sets. But whenever you use a data set, you should be very, very careful that what are the sources from where you have acquired it and how are you using them. And when you try to combine all the above to make a system, we call it a network. Now, this is the components of GIS. When you have people, when you have hardware, you have procedures, you have data, you have software, and then you try to integrate all of them in a network, in a loop, and this is what comprises of GIS. Now we have subsystems of a GIS because GIS in itself is a huge system containing few broad subsystems. The first one is data input subsystem. Now data input subsystems includes pre-processing and transformations, data storage and retrieval, organizers for retrieval, editing, and updating. Similarly, when we talk about data manipulation and analysis, you have aggregation of the data, disaggregation of the data, and you can even go for modeling exercises. Now comes reporting. Whatever you have worked needs to be reported. This is the output where you are more concerned, and these outputs could be in tabular form, graphic form, and in most of the cases we have in the form of a map. Now we move to the next, and that is types of GIS. There are a number of geographical information systems available today. They range from high-powered analytical software to visual web applications, and each of those are used for different purposes. Due to vast number of GIS available, it is simply not possible to provide training to each individual software here. However, there are common features in all the GIS softwares. Understanding these basic features will give you confidence with any GIS system that you work in the future. And these are different types. You have web-based GIS, that means online navigation system. You have geo-browser like Google Earth, and you have desktop GIS, for example, ArcGIS. Now we come to a very, very important aspect, and that is the types of data in GIS. Because since I told you in the beginning that we are going to derive information out of the data sets, we are going to cull out the information out of the data sets, so it becomes all the more pertinent to know what kinds of data we are going to work with. Geographical information system is different from other kinds of information and therefore requires special methods to be analyzed. Here are some of the characteristics that make geographical information special. Multidimensional, at least 2 coordinates must be specified to define a location. Voluminous, a geographical database can easily reach a terabyte in size. Different representations, how is it to be done, and how can it strongly influence the ease of analysis at the end of the results is to be seen by a researcher or by a GIS users. It requires to understand a projection because whenever we map, we have to use a projection taking into consideration the spherical curvature of the earth, and when we draw a map, we don't take this curvature into consideration, and there are projection techniques to take care of that. We require unique analysis methods, for example, overlay, buffering. We analyze required data integration. Yes, I have been emphasizing that with the help of this technology, you are able to integrate the spatial and the attribute data. And when you link the data with the help of GIS, that is the beauty of a GIS software. Data updates are expensive and they're time consuming too. Map displays require fast data retrieval. This is how we understand. We have data which can be classified into spatial and non-spatial. Spatial data further has two modes of representation, or you can call them as two models of spatial data. There are vector and raster. For example, we have different locations, and these locations, when they are abstracted on the map, here one needs to understand the relationship between a map, which is going to be your final output, and the GIS technology which you are going to use to create a map. All the maps we create are related to the geographical environment around us. They are supposed to be depicting the real world. But when we depict the real world, we don't depict as it is. So each map you create is an abstraction of the reality. And one must keep this into mind, because the entire philosophy of representing the data on a map depends on it. For example, where have you to use point locations? Where have you to use line locations? Or where have you to use polygon? This all depends upon the dimensionality of the data which is under consideration. Because when you use data which is linear in form, you try to use data with symbols of lines. Because when we talk of map abstraction, this in turn follows that we abstract the objects with the help of symbols, and this entire technique is known as symbolization. And how do you portray the real world on a map is guided by the principles of symbolization, which include the consideration of dimensionality of various objects. Whether you are going to use point, whether you're going to use line, whether you're going to use polygon, shall all depend what is the dimensionality of an object which you need to show on the map. When you talk of raster, you can have continuous raster data and you can have discrete data. Raster means when you try to show data in the form of pixels. And vector is when you join the data from point to point, and whatever maps you see are all vector-based maps. Now, when coming to non-spatial data, it could be different models. You can have network data, you can have hierarchical data, and you can have relational data. Now, this is a spatial data, what it looks like. And this is a geospatial data because it is dealing with location, size, and shape of any object on planet. For example, it could be a building, it could be a lake, mountain, or even a township. Now, these are two models by which spatial data can be represented. You have raster, where you have pixels. The first diagram where you can see those square, these are the pixels. And similarly, if you're trying to show the same in the vector, it will be something which is shown in the vector layer. Because vector layer is using polygons because you're trying to deal with the aerial dimension of the data. Now coming to vector. Vector in GIS is a format which stores information about any feature of the earth in three different types or objects. Polygon, also known as regions, line, known as arc, and point. Vector structure starts and has endpoints of a line which are called nodes. Any change of direction on a line is a vertex. Lines are joined by sharing a common node. Polygons are joined when they are adjacent to each other if they share a common line. Vector objects are all created from the general graphic representation of single XY coordinates. Points are single coordinates, lines are strings of coordinates, and polygons are a closed string of coordinates, often composed of multiple lines. Now, this is how spatial data looks like. This is the diagrammatical representations of the vector data. Vector where each object is composed by a series of X and Y coordinates You can take them in pairs also. You have points where you have single XY pair. You have lines shown on this where nodes at beginning and the end, vertices for changes in direction along a line, and polygons are closed set of lines. Spatial data, raster. Raster is the set of rows and columns that form individual cells. Each cell or a pixel has a unique data value and clearly has an area coverage proportional to the cell size. Raster cell is also known as pixel. Raster data is also known as grid data, and this represents the fourth type of features, that is surfaces. Raster data is cell-based, and this data category also includes aerial and satellite imageries. Whatever data you procure, whatever spatial data you procure from in the form of aerial photographs or satellite imageries is in form of raster format, where you can see the data in pixels. For example, in this picture, this orange is showing you the built environment, blue shows water, and this is how it has been depicted in the raster. Had it been vector, you would have different polygons for it. And the green shows the forest and the wetlands. Now coming to the types of raster data, we have continuous and discrete. An example of the discrete raster data is population density. Continuous data examples are temperature and elevation measurements. And when you have to work on these kind of data sets, which either are discrete or continuous, you can use them the way we have used it. For example, if you are showing a map of contours where elevations are being shown, this is a continuous phenomena, and it will be shown like this using different colors. And if you are trying to make a district map where you want to show population density, you can have different class intervals, you can assign different colors to it or different shades to it, and then you can make a map. Now this map would be a discrete map because there is no continuity. Now this is how we have thematic and spectral data. Thematic data is based on one theme or multiple themes. Digital elevation models, which are known as DEMs, are the best examples. The spectral data includes data captured at different wavelengths. One wavelength is suitable for few types of features, producing one data layer. Other wavelength is used for different types. You must have studied this in the remote sensing also. And when we use different data layers of different wavelengths, they combine to form one scene imaginary or an imaginary, which is formed like this, as it is clearly depicted in the diagram. I'm very sure when you must have done remote sensing, you must have covered this. Now this is the difference between vector and raster. The raster view of the world. Suppose you are going to show the location of hotels on a map. In the central column, we have spatial entities which are supposed to be represented on the map. And in the first column, you have the raster representation, and in the last column, you have the vector representation of the same. For example, the first is the location of the hotels, and hotels would be shown by points. Now you can see in the raster, these point locations are shown as pixels, whereas the vector view of the same object is going to be points. Similarly, when we come to the representation of the lines, which are the ski lifts being shown in this, the first representation is raster when you have a row of pixels, whereas the vector view has points joined by lines. So this is a linear representation of the data. When it comes to forest, which is of course an aerial dimension, the raster representation shows number of pixels together to form an area or a forest. Whereas a forest in the vector view is nothing but an area which is shown by number of points and joined them together. Look how the network of roads will appear. Similar network of roads in raster will appear as pixels in a linear form, whereas in the vector view you will be seeing arcs and nodes. So this is how you differentiate between vector and raster. Now coming to non-spatial data, which is also known as attribute data, any attributable information related to a feature like building, construction material, building's height, building's occupancy, which can easily be recorded in tabular format and is attached to the feature when it's opened in GIS environment, is known as non-spatial or attribute data. It can also be stated as an attribute data, generally defined as additional information about each spatial feature housed in a tabular format. Now, there is a spatial data where you see number of colors, 1, 2, 3. These are different regions or areas. But when you have attributes data, this is how you will have. You can have area, you can have perimeter, you can have type. The type could be further. This could be used for a soil profile. Over here, we are trying to use a soil profile, and then we give the area and perimeter in the first instance, and then the type can be further classified, where you can have clay, silt, sand, and then you can go for sedimentation, or you can go for any number of attributes. If it would have been a geographical region, you could have gone for elements or attributes like population, population density, literacy rate, sex ratio. If it would have been a biogeographical region, you could have gone for flora and fauna species. If it was a meteorological data, you could go for temperature, pressure, wind velocity, so on and so forth. Now, the tools for GIS. We have to cull out information, as I have been emphasizing on, out of the data. And this data we acquire either from remote sensing data, or we can have geographic data in the form of maps, which are prepared by so many agencies, especially the Survey of India. You need to work on hardware, where you have a computer, a digitizer, a scanner, a printer, or a plotter. Similarly, you need to have software. You need to have desktop GIS. You can work on internet GIS. You need to have softwares, database softwares. And these days, when you are working on multimedia, you can have even 3D models. 80% of the government data collected is associated with some location in space, and we call it geographic data. If you go to the largest organization of census of India, which gives you a large gamut of attribute data, mind you, all the data is collected by locations. There may be villages, there may be towns, there may be cities, there may be million-plus cities or mega cities. There could be states, there could be tehsils, there could be talukas, and there could be village boundaries also. Similarly, information on attributes or the characteristics which you call as data can be used to symbolize, as I've told you, and provide further insight in a given location. System, of course, is a seamless operation linking this information to the geography, which requires hardware, networks, software, data, and operational procedures. And that is why you need to train yourself on a software before you use that software, and you need to learn the functioning of the software, and for that you need to have a familiarization with different modules that are available in the software. So not just the software, not just for making maps, you need to have a holistic appraisal of the entire GIS software which you intend to use. Now there are so many functional elements. The first is data acquisition. When we talk of data acquisition, we need to talk about the sources from where you will acquire data. as I've just told you, there are so many agencies from where you can acquire data. The agencies where you are going to look for spatial data are going to be very, very different. Similarly, the agencies for attribute data are numerous. It is for you to decide from where will you collect data, but before working in a GIS environment, it is for sure that you have to acquire data, and this stage is known as data acquisition. When you have acquired data as per for your requirement, then you digitize it. When you try to digitize it, you are liable of committing some mistakes, errors. When you correct them, you edit them. Then you need to build mathematical relationships of those data, which is known as topology building. You are going to use different projection transformations, and you need to understand what are projection techniques. Now, these techniques are the techniques which try to bring this spherical Earth on a flat surface. So you need to know what kind of projections will be the best suited for your areas and for your purpose. Similarly, you have to think about pre-processing also. It could be analog to digital, or it could be conversion of units. Similarly, management would include data archival databases. That means you could have hierarchical model, network model, and relational databases, etc. Now, these databases are supposed to be managing your attribute data. Now, attribute data can be in hierarchical model, it could be networking model or relational database. When you use it in a hierarchical model, it is like parent to child relationship, and you have a hierarchy and you have hierarchical paths to reach somewhere. When they are in networking model, these data elements are going to be linked with each other. The relational database uses rows and columns, and this is the largest database model used in various softwares, because this is very easy to operate. If you want to update your data, you can. If something goes redundant, you can delete it. So relational databases are very, very important, and they're very common to the use of GIS softwares. Then you go for manipulation and analysis. These are the different capabilities of GIS softwares for spatially analyzing the data. They may be overlay, they may be buffering, connectivity operations. We are going to discuss them in detail in a few while from now. Now, these are the benefits of GIS. Once a GIS is implemented, you have numerous benefits. First of all is better maintained data. Now, better maintained data means you go for a database management system, which you call it as data DBMS. And why do you need database management system? You need database management system because you're going to work with huge sets of spatial and non-spatial data. You can have standard formats. You can have easy revisions, easy updations. You want to update your data? Create a column, create a row, and you can add the attribute information. If you find data has gone redundant, delete a row, delete a column. You can have conversion of the units, which is very easy. You can use it to search, analyze, and represent. And you have many value-added products. You enhance the productivity of the staff also. Time and money is saved. And of course, one must realize that the ultimate use or the goal of using these data sets are better decision making. GIS is a decision making tool. It is known as a decision support system. We always use GIS whenever we are to solve a problem. That is why this tool is becoming very, very popular with the government when they have to take decisions. It is becoming very, very popular with the corporate sector. And it is very, very important with even realtors these days. Whosoever is working with spatial data, this technology becomes very, very important, and it helps you to take decisions which are objective, one, precise, two. So if you want to go for an objective decision making, a precise decision making, and you want to solve the real world problems which are around you and the problems related to the real world, you can easily use these techniques and you can work in GIS environment. Now, GIS is being looked upon as a multidisciplinary science. Why? Because combination of following traditional sciences have contributed in making of this technology. Geography, yes. When you work on locations, you work with geography. If you have to portray the real world around you, if you have to look for different problems which are facing the real world, and if you're trying to find out solutions for this real world, you need to have a good geographical knowledge. Geography enables you to understand the linkages which exist on the earth, whether it is physical environment or it is human environment. Whatever problems you are trying to solve normally are the outcome of these linkages, or I must say mislinkages between the human and the physical environment. The second major contribution of geography is cartography. Cartography is art and science of making maps. The final product which you desire is a map. Unless and until you are clear with the concepts of cartography, you cannot use GIS in an effective way. So you should be having a fair good idea of the cartographic techniques which you require whenever you make maps. You should be knowing what kind of techniques you are going to use when you have to plot a point data. When can you use a linear data? When can you differentiate between different linear data, and so on and so forth. And for this, you need to understand the art of symbolization and the art of graphic representation. You need to understand how do you make an output, map output, and how do you balance your map? Where are you going to write a title? Where shall the legend be? Because map, when you create out of GIS, it is going to communicate with the audience, with your readers. Statistics. So many statistical calculations are there. Cartography, I have already taken up. Remote sensing. This is one of the major sources of acquisition of data. Photogrammetry, computer science, operations research, mathematics, surveying, civil engineering, geodesy, environmental planning, and urban planning. So these are different multidisciplinary sciences which are using GIS as a software, as a technology to find out decisions for various problems. All these work on spatial data, and anybody working on spatial data can make use of this technology. Now, whenever we talk of GIS softwares, there are so many softwares which are available in the market. You have ISRI. ISRI is a company. You have ArcInfo, ArcView, ArcGIS. Then you have, and Idrisi is a very, very easy software to work with, and it was made by the Clark University. ILVIS is another. Integrated Land and Water Information System is another software, and there are numerous softwares. Now, one must realize as what are the advantages and disadvantages of using GIS. Advantages are many. You explore both geographical and thematic components of data in a holistic way. Now, what does this mean? This means that you have spatial data on one hand and you have attribute data on one hand. When you try to get, or when you try to link the spatial and the non-spatial data, there are so many combinations of the data you arrive at. And when you use GIS, it enables you to unfurl those relationships which you couldn't have understood otherwise. And when you try to unfurl a layer after layer, a layer of information, another layer of information, and then you can combine them also as an holistic way. So from part to whole and whole to part, both can be used to study different phenomena on the earth using GIS. It stresses geographical aspects of a research question. Whenever you have a research question in mind, it begins with where, what, why, how. These are questions which have a geographical input. Starting with the question of where, it becomes very, very important if you have to locate a school in a village. Now, not going by the whims and fancies of the people and trying to go for an adequate location, you can pose a question, where have you to locate a school in a village? Or if there are opportunities available in a city and you want to come up with a mall, where shall it be located? Now, these questions do not have easy answers, and you need to work on number of indicators of data, and then you are able to suggest a good site to them. Such questions are known as research questions on the locations of different phenomena, and this kind of exercise is in GIS environment is known as site suitability exercises. GIS allows handling and exploration of large volumes of data. Yes, we have been working on large volumes of data, and the tragedy was that we could never ever update that data when we were working in the conventional modes. We wanted to store that huge amount of data but did not. Now with the help of this technology, we can use this data, we can handle the data, and we can use whenever we want. And if we analyze and at some point of time that the data has gone redundant, you can delete the obsolete data and you can go for the newer ones. It allows you integration of the data from widely disparate sources. Yes, you have n number of sources for spatial data, you have n number of sources for attribute data, and this technology allows you to integrate both the spatial as well as the non-spatial data. This is the beauty of a GIS software. It allows analysis of data to explicitly incorporate location. Let me tell you, whenever you're working with GIS, one thing has to be understood in letter and spirit, that you are going to work on locations. And when you're working on locations, any problem related to location is going to be your favorite arena of working in GIS. When you're analyzing data and you are trying to explicitly understand the locations, it helps you to do that. And any problem which is related to that location becomes your focus, and GIS will definitely and certainly give you answers to your queries. It allows a wide variety of forms of visualization. These days, we are talking of 3D visualizations. We are talking of modeling exercises. And let me tell you, GIS has been very, very useful technology and a tool in doing this. We are being visited by a number of disasters. Now, it is possible for the experts to go for flood modeling. If you have to prepare and if you have to show preparedness for a disaster, and if you want to reduce the risk of a disaster at any place, you need to work out the things much in advance. And let me tell you, friends, people are going for flood modeling, and they are able to predict the floods which are going to be occur in future with different permutations and combinations of the rainfall data. And then they can always be used as a guidelines when you want to prepare for the disaster risk reduction of floods in a particular area. And we are working with 3D GIS these days. We can create digital elevation models. We can just have a 3D visualization of the entire world or an area, whatever you're working on. That doesn't mean that there won't be limitations. There are limitations of GIS. Data is very, very expensive when you use in GIS. Learning curve of GIS software can be long. Yes, there are so many modules in a software, and you take a lot of time when you have to learn these softwares. Sometimes you need to have an appropriate training. You have to be adept in using this, and this curve can go very long. But once you are able to invest time, then you are able to reap the benefits also. It shows spatial relationship, but does not provide absolute solutions. Here lies the power of a thinking mind. It is going to show the spatial solutions. Yes, it will analyze the data for you, but it is for the human mind to interpret it. Yes, I was talking about how the spatial relationships are studied, but they don't provide absolute locations. These are technologies and these are tools when you can analyze the data. You can process the data, but when it comes to interpretation, it is the human mind. It is the power of human mind. It is the expertise which comes into the way. And when you are able to add your expertise and your interpretation, then only you can reach absolute solutions. There are origins in the earth sciences and computer sciences, and solution may not be appropriate for humanities research. For social sciences, many a times which do not use the location data or the spatial data, this GIS may not be very handy. But if one realizes the power of location, then you can use this for social sciences as well. Yes. I would like to invite questions now.